Here's an interesting project that just launched and has had its first release, a new runtime environment running Linux in the browser, or what's known as WebAssembly. This project here by Joel Severin was announced to have built the Linux kernel under WebAssembly or WASM, allowing the full Linux runtime to execute inside of web browsers. It's a pretty big milestone for Linux, as running the kernel in browsers or WebAssembly opens it up for new possibilities, including things like sandbox, experimentation, teaching, and portability. We're going to be checking out the project and actually testing it out in a browser briefly. So let's get into things. A few days ago, this project became public, which allows you to build and run a Linux system that can be executed on the web via WebAssembly. And you can directly host it on your machine or host it in a Docker container. And it's currently based around Linux kernel version 6.4. So what exactly is this project for? What does this mean for Linux? Let's get into this by seeing the submission from Joel Severin on the Linux kernel mailing list. Hi, during the past 2 years or so, I've been slow rolling an effort to port the Linux kernel to a WebAssembly. I'm now at the point where the kernel boots and I can run basic programs from a shell. As you will see, if you play around with it for a bit, it's not very stable, will crash sooner or later, but I think it's a good first step. WASM is not necessarily targeting the web, but that's how I have been developing this project. Since the current state is a web-based demo, I'll drop a link below. We're going to check that out. This is Linux booting in your browser tab, accelerated by WASM on a decent computer. It should boot in under a second, which is quite wild to think about this. The Linux kernel itself can be ran inside of your web browser and leverage actual hardware acceleration and system level operations. In other words, Linux, the same one that runs on your PC servers, is now being executed inside a sandbox virtual machine running within another runtime, WebAssembly. That means you can literally open up a tab and see Linux boot and start using it almost instantly. As they say, the boot time here could be under a second depending on your hardware. But it also means it doesn't just run on your PC or your computer. You can use it in any browser, meaning on mobile phones, TVs, game consoles, whatever you can access the web with, you can now run Linux. Let's continue on, as unfortunately my hosting provider, GitHub Pages, does not provide the right co-EP HTTP headers for this to work. Spectra mitigation. I guess I got what I didn't pay for. I found a workaround that often works, but the page takes longer to load and sometimes breaks, especially on some mobile devices. Reloading the page may help. Looks like Joel needs a little help trying to host this project, as GitHub Pages offers a free way to host your pages. As the project takes off, I'm sure this will become no problem hosting this on some actual cloud server. But either way, now this is a technology demo. It's to show what's possible. There are some things where what we have today makes this more powerful than it has to be. The good news is that if there is a will to go forward with Linux and WebAssembly, at least I don't see why the current restrictions cannot be lifted, but there would need to be a commitment from Linux and WebAssembly people, not to mention the whole ecosystem around it, to actually implement those changes. Some fundamentals of each platform would need to change for a smooth experience, especially on the WebAssembly side. It's very cool to see a project like this. Again, portability, a place where you can safely experiment for education purposes, like teaching Linux to new users. And who knows, maybe even a future target architecture under WebAssembly for real sandboxed kernels. And if you find this interesting and you would like to join in the development, please let me know. I'm especially looking for competent people who can help with atomics and locking in the kernel, but also scheduling, or just general development in the kernel and or the ecosystem around it, such as compiler or userland infrastructure. It's interesting that they're already thinking about userland infrastructure, meaning the graphical side of things. It looks like it's not just going to run a terminal. Eventually, Joel wants to be able to run a full Linux system. So overall, what does this mean for us? Well, now Linux boots completely in the web browser, no virtual machines, no emulation, pure WebAssembly. Of course, this is a proof of concept, clearly unstable, but it does actually boot, and we're going to go try it out and run simple shell commands. You don't have to install things to get a Linux environment anymore. No virtual machines, no emulators. And here's what things look like in the browser. This is Linux running on WebAssembly. Things have loaded in. It didn't take super long for this to load. Right now it says it's a node with 3 CPUs. and it's pretty sweet to see. What can we do with this thing? Well, it has some examples below, but let me see if I can type something in. Look at that. ls lists the current directories. We're in the home user directory, so we got bin, etc., init, mount, root. Interesting. I guess we aren't in the home. There we go. We're in home now. Either way, we're moving around the system. I'm going in and out of directories and listing the contents. Let's see what something like dev looks like. Just console. Okay, interesting. How about our bin? Look at that. This is some of the binaries that we have installed on the system, including file system check, some of the networking stuff, IP here. We got make file system, turning swap on and off. Let's see if we clear things out. Yep, that works too. And we watch the current uptime. We have this completely messed up. No big deal, as I guess it cannot get time from the system. Now, how do I exit out of this thing? Well, that was clearly a mistake because it looks like I actually crashed things here. So again, very much a proof of concept. Not everything's working properly, but a simple reload tends to fix things. I can also run top, for example, to see what exactly is running on the system. Pretty neat to see that just about nothing is running on the system with no CPU overhead, hardly any memory being used, 11 megabytes out of 500 megabytes. All right, I was successfully able to control C that time. Let's just see if I got GCC or something on here. What if I tried creating a new file? That'd be kind of neat. So if I did VI, or maybe even, let's see, Vim, no, VI, and I did some.txt, look at that. Let's see if we can save this as well and just practice VI in the web browser. All right, so Savvy was here, and I'm going to save and exit out of this. Let's see if that works. All right, panic as we tried to run it and broke the stack. Let's see if we want to catch that panic. Sure enough, it stopped all CPUs and we killed the interrupt handler, meaning we reached a kernel panic, but don't panic too much. Just refresh the browser and you're back. So a lot of work to be done, clearly. It's still very exciting as this was just released a few days ago to the public and it's already running in browsers. That's a pretty big milestone in my opinion. What also would be a milestone before we get into more of this, if you went down, subscribe below and smash that like button on the way back up if you enjoy videos like this. Let's get into what else we can do. The console can use Control-C, and depending on your platform or browser, you might have to actually hit Shift. You can copy and paste as well using Control-Insert and Shift-Insert. So what were we watching? The Linux kernel booting in your browser powered by WebAssembly. The included programs, shell and standard commands are provided by BusyBox, backed by MUSL libc implementation. The terminal emulator is provided by xterm.js. This is a proof of concept to get a discussion started, not a stable nor a secure system. Many workarounds, hacks are needed to pull this thing off. Maybe this tech demo can steer development of WebAssembly, Linux, LLVM, and the other components needed onto a path where WebAssembly powered Linux systems can be supported in a production setting. But there is a long road ahead, and all platforms need to change in fundamental ways for that to happen in a convincing way. Not to mention the human aspect. Do all stakeholders even want to support such an odd platform as WebAssembly or niche use cases it currently caters? Which I do enjoy how pragmatic the developer here is being. It's straight to the point. Does this even matter to Linux? As Joel mentions explicitly that there are many current hacks and there has to be fundamental changes, and whether or not this is even a good idea in the first place. This is something to be answered by users and not by the developer pushing something on you. I do like the approach here so far. So the known bugs, quite a list of them. Main one being that the whole system will lock up. We've already seen some kernel crashes, but for the most part, reloading the web page works. I'm going to put a link in the description below so you can also try and play around with this. And it is recommended that you use Chromium-based browsers over things like Firefox, and that there is a ton of instability. So let's talk about how this works. WebAssembly is similar to every other architecture in Linux, but also different. One important difference is that there is no way to suspend execution of tasks or task. There is a way around this though. Linux supports up to 8K CPUs or possibly more. We can just spin up a new CPU dedicated to each user's task, process, or thread and never preempt it. Each task is backed by web worker, which is a practice backed by a thread in the host operating system through the WebAssembly implementation. This essentially offloads the actual scheduling of each task in the Linux WebAssembly guest to host operating scheduler. as the guest kernel has been tricked to have a lot of CPUs that ping pong between executing a single user task and their own idle tasks, and some K threads now and then. As we know, they play nice and won't hog the CPU. They can execute for a brief moment on any CPU in the guest system. No graceful preemption also means that interrupts or signals won't work fully. There is some support for interrupts on dedicated CPU. It is used to deliver timing interrupts and IPIs that control advanced scheduling. IPIs, I believe, are inter-process interrupts. Signal handlers only work if the users play nice. If all threads never do any system calls, i.e. hog the CPU, the signal can never be delivered. Thankfully, most programs play nice, and those that don't should be easy to fix one way or another. So what are the current limitations? Well, no interruptions, no memory management unit. Every process in the kernel currently lives in the same address space. WebAssembly is also a more or less strict Harvard architecture, where code can be loaded but not modified at runtime. The just-in-time compilation could work in theory, but would require, again, some hoops. And is it optimized? Well, of course not, as there's a lot to do before you reach optimizations. So a big question is, how does this actually differ from previous attempts of trying to port Linux into the browser or be able to use it from the browser? Well, let's talk about that. But before we do, if you want to level up your Linux experience today, check out my checklist, cheat sheet, and my map, all available at SavvyNik.com. Download them today. How does this differ from previous attempts? Linux in the browser has been done a few times before, either by slow emulation of other architectures in WebAssembly or even pure JavaScript, or by running Linux as a library. Such attempts have inspired this more direct approach. The goal is to expose system calls that Linux kernel provides. This should allow porting of many more programs than possible with WASI, or the current generation of Emscripten. Note that the program does not necessarily have to run as a process inside of Linux either. You could just have one or a few front-end threads that you use for system calls, possibly via some kind of message passing. This way, your program does not have to live inside the memory space shared by the kernel. It is completely sandboxed. The limitation of such an approach is that you would not be able to share memory between programs. So to simplify this a little bit, current implementations on Linux in the browser, or at least attempts, are slow and limited. This project takes a more modern, direct approach, which exposes the Linux system using calls through WebAssembly, meaning that the programs can use Linux's core features just like a normal system and not through emulation. And if developers choose to run full Linux processes inside the kernel, or keep their app fully sandboxed and just call system functions through message passing, the trade-off here is that if you separate things like that, you'll lose shared memory features. Past attempts have tried to fake Linux out. This one here will run and expose itself in a way where system calls are actually being made and has a more realistic behavior with compatibility inside of browsers. So if you want to start helping out, you can run your own instance in either Docker or on a host computer. But what's next? According to Joel, getting some kind of graphics working would be fun. One could try to implement EGL and WebEGL as a backend, exposing an open GLES interface. Emscripten seems to already have a good portion of this work implemented. Another area worth exploring is dwarf support, to be able to debug line by line in C code. This would be fairly easy to add, and most browsers support it, but I didn't bother as I didn't want to learn the WebAssembly instruction set. That could teach you better than following along the assembly listing and cross-referencing each instruction to see a C statement. Possibly optimized and inlined. You can even learn the compiler's WebAssembly specific tricks. I have not tried C++, but I think it may require some special attention. Just like set jump and long jump, exceptions need to be handled in a graceful way. WebAssembly has native support for this, but it may need some tweaking to work. And there is libcxx, and who knows what crazy situations that beast may put on to you. Looking further than web as a platform, WebAssembly also shows promise in other applications that need multi-platform sandboxing. Examples include smart contracts, multi-platform apps, GPUs, agentic AI, and your next hype. The wish list here is a memory management unit for sharing and protecting memory, thread suspension, moving away from custom WebAssembly binary formats to ELF for tool compatibility, being able to share WebAssembly instances between workers, and being able to set breakpoint on memory address in the debugger. So in summary here, Joel made the Linux kernel run natively inside of web browsers, not through emulating, but actually porting the kernel. It's currently booting, as we can tell, and is a very early prototype. He's currently inviting other developers in open source to help with atomic operation scheduling and helping the debug effort. This is pretty cool and important for Linux and open source. It's a new architecture target. WebAssembly could become a new architecture. Now that we've to an extent proven it could work, and it helps us with security and sandboxing. Running Linux in WebAssembly offers a new model for safe kernel experimentation. It also helps with portability. Now anyone can run Linux in a browser instantly, no installing, no virtual machines, just an awesome way to easily access and spin up Linux practically anywhere. Overall, it shows that Linux can run in the same sandboxed model as the modern web and makes it a very cool project and experiment. We'll see how things pan out over the next year. Is this a waste of time? Do you see a use case for it or for yourself? I'd love to hear from you in the comments section below. While you're down there, make sure to subscribe and smash that like button on the way back up. Catch me in a great community on Discord, and I'll catch you in another video. Thanks for watching.